Welcome to the final part of Chapter 8. In this section, we're going to start talking about problem solving with one-step and two-step synthesis problems. When you learn these new reactions, so all of these addition reactions, the substitution reactions and elimination reactions from Chapter 8, these are one-step synthesis, right? You have a starting material, a reagent of some sort, and then you are usually predicting the product. And so you have to memorize all of these reagents and be able to predict products. That's where it's important that you know regiochemistry concerns and stereochemistry concerns. It's when you start to think of the words Markovnikov versus anti-Markovnikov, syn and anti-addition. With substitution, you had to think about stereochemistry. With elimination, you had to think about Zaitsev and Hoffman, right? So it's complex. You have to memorize not only the reagents, but what kind of product they produce. But there's also going to be problem types where I give you starting material and product. And you have to think about all of those same concerns, but then provide the reagent. What that is setting us up to do is to start telling a more interesting story where more than one reaction is needed. And so, again, you have to keep all of these things organized, right? So if we look at, as we are starting to move towards 2+ step synthesis problems, we want to take things like this into consideration. What is happening? We have a double bond and we are making an alcohol. So we are adding water across the double bond. So it's an addition reaction. It's from this chapter. It has Markovnikov regiochemistry. The OH is on the more substituted side. Now, for a problem like this, there is more than one correct answer, right? We know that we could use dilute acid to give the Markovnikov addition of water, or we could do oxymercuration, demercuration with mercury acetate and water, followed by sodium borohydride. And so you have the first option here, H2O and H2SO4. It's the same thing as H3O+, right? It's a dilute acid. And we know that there's multiple options. If we start to utilize these reactions, we start to put them together, we can do even more than just a simple substitution or an elimination. We can actually start to move around functional groups. And so there's a whole chapter on multi-step synthesis that we're going to cover in Unit 4, but this is going to help us build to that point. So we're going to be looking at moving functional groups. These can often be done in 2 steps. Moving functional groups. So it's either going to be an elimination addition or an addition elimination. So when we move a bromine, first we're going to eliminate, and then we're going to add the bromine back. And so we can utilize all of these regiochemistry, regiospecific reactions to achieve this. So when we eliminate, notice that we are getting the Zaitsev product. And then when we add, we are looking for a Markovnikov product. So how can we eliminate to give Zaitsev? Well, we want to make sure we use a base, but not a bulky base. So something like NaOH or NaOMe to really help us not do a substitution. We could also just make sure that we put it in a protic solvent. So something like sodium hydroxide and water. Then when we move on to, and let's see, I think it's on the next step. There we go. So you had your 2 options for eliminations, right? So A lot of times people will ask me as we go from unit to unit, well, is this only going to have new material on this test? No, it never can be that way. We are building on what we've learned. We will have nomenclature on every test. We will have chirality in some regards. We will have substitution reactions and eliminations. As you can see here, when we start to do two-step synthesis, what you're doing is you're building a toolbox. You're building a toolbox of reactions that you are going to need to be able to pull from. And so while each exam will focus on new material, you have to have that old material at your fingertips. And so this is that toolbox, right? I have two tools to give a double bond. One that gives Hoffman and one that gets Zazef. Since I want to move that bromine to the right here, to the right, I want to get that Zazef product, that more substituted product. So you can use sodium methoxide. You just want to use that smaller base, non-bulky base. Then when we go to our addition product, we want that Markovnikov, right? So we have two options for adding HBr across a double bond. You have HBr by itself or HBr and peroxide. If you did HBr and peroxide, you would just go back to making the starting material. So you want to just use HBr to put the bromine in the desired, more substituted position. You can do the same thing with an alcohol, right? Because we've worked with halogens and alcohols. We are taking this OH and we are moving it to the less substituted position. So we're going to go through a double bond. First we remove the water and then we add it back. Now, something that's important to remember is moving an alcohol is a little bit different, or eliminating an alcohol is a little bit different than eliminating a bromine. You can just use sulfuric acid, but that will give you the Zazef product. To get the Hoffman product, we do want to use a bulky base, but that has to be step 2. Because a base will not remove an alcohol. You have to make it a better leaving group first. And so to make it a better leaving group, just like you saw in chapter 7, you're going to use tosyl chloride and a little bit of pyridine. And that will allow you to get the Hoffman product. Now you could also, instead of doing H2SO4, hold on, let me make this a little smaller. There we go. You could also do tosyl chloride and pyridine and just follow it with sodium methoxide, right? Or sodium hydroxide. So there are options. As we learn more and more reactions, these synthesis problems get more interesting. There are often multiple correct responses. And the reason I want to point that out right now is if you are working on a synthesis problem and your friend gets a different answer than you have to think more critically than just like, oh, one of us is wrong. One of you may be wrong. You might both be wrong. You're both new chemists coming up with synthesis solutions. But you could also be right. There are sometimes multiple correct answers. It's also important to know that that's a possibility when looking at solutions. A lot of times when I put up practice exams and practice sets now, you're going to see possible solutions instead of solutions at the top. And if you are ever concerned or think, I think this is correct, but it looks different from the answer key, send it to me. I am happy to look at it. I can tell you if it is right or wrong. And I can help you understand why if it is wrong. So please stay in touch with me here. So as we go through this, we have one option that gives us that Hoffman product, right? Going back to the problem we were looking at. So we want to eliminate using tosyl chloride and then tert butoxide. You can show it one of two ways. You can show each reaction in the intermediate product like this, or you can do a 1 and a 2. You will lose points if you do not use your numbers when you have numbered reactions. Because if you put tosyl chloride and pyridine and TBUOK on the same arrow with no numbers, that will not do what you want. These are two separate reactions that are done separately. Now, once you get your alkene, now you want to add water across the double bond to give a anti-Markovnikov product. Anti-Mark. Oh, I did not. That says anti-Mark. There is only one reaction, that can do that. It is a two-step process, needs the numbers. But you're going to have BH3 followed by peroxide and hydroxide. So you have to have all of these reagents memorized and know about their stereochemistry to get full credit on problems like this. Now, with multi-step synthesis problems, there is always opportunity for partial credit. So, for instance, if we had this example here, and let's say you knew how to do, you knew that you had to get to this product in the middle and then out here. But let's say you have no idea what to do in this step. Well, there's no reason that you should get 0 points if you do know that you need that anti-Mark product. So what I recommend doing is telling me what you do know, right? Make sure that you know that you get out the information that you do recall. And you can always put just elimination, right? You know that it's a Hoffman elimination. Put that information. You'll get points deducted for not knowing the reagents, but you can help yourself accrue partial credit if you do write down what you do know, right? So when you are tackling a synthesis problem and you don't know a piece of it, it still benefits you to try to work through what you do know, I promise. All right. We can also change the position of a double bond. It's the same process. It's just if we are moving a double bond, we're going to do the addition first and then the elimination. Right? And again, we're still considering Mark, anti-Mark, Zaitsev, and Hoffman as we are doing this. So when you want to add the bromine in the direction that you want to move the double bond. So you notice here we need that, it's already written, the anti-Mark addition of bromine. We want the bromine to go to the less substituted this side this time, and then do a Hoffman elimination. And so how are we going to do that? Well, we're going to use HBr. I know it's written over there, but we're going to show the steps. HBr and ROR, right, our peroxides. We'll put that bromine in the less substituted position, and then we can use our tert butoxide to get that Hoffman product. Klein does a great job with reviews. You need to know all of these reactions. The spider diagram that I gave to you on eCampus also gives you a visual image of this. He also has his own spider diagram. You could just print this one off. The spider diagram that I gave you on eCampus, if you scroll down to the second page, it has the diagram, but all of the products are blanked out. So you could use that as a drill for while you're memorizing it. I will also in a few days put out a list for exam 3 that says, which reactions you have to know, which is all of the ones we've learned, but then also I'll break out which mechanisms you need to focus on. This is a great thing to print out. So I did the one where I blanked out the products. Klein provides you with a sheet where he blanks out the reagents. I highly recommend printing out some of these blanks because you can use them to drill as a drill until you get everything memorized. If you're a note card person, that also works. I never made note cards fast enough to be useful. So I really like these kind of slides, these kinds of images to help you practice. And then just lots of good review slides for you as you're studying.